Welcome to Session 4, 1, None, or Infinitely Many. This lesson strengthens algebra that remains reliable when the numbers or representations become unfamiliar. You will learn to recognize when variable terms cancel completely, to distinguish a contradiction from an identity, and to connect algebraic outcomes to parallel or coincident graphs. Treat these as connected habits. Keep a pencil ready. We will build a visual model, use a repeatable process, solve a demanding example, diagnose an error, and finish with a checkpoint. Start with this picture. Equivalent operations preserve balance even when the variable eventually disappears. Both sides reduce to the same constant, every allowed input works. If they reduce to unequal constants, no input can restore balance. The key distinction is this. Recognize when variable terms cancel completely. Then connect it to the second goal. Distinguish a contradiction from an identity. Correct methods begin with correct interpretation. When a problem looks different, look for the same mathematical structure instead of an identical example. That transfer makes the skill durable. Step 1. Distribute and combine each side independently. Identify the object being changed and the requested result. Step 2. Move variable terms together without assuming a solution must remain. Use a separate line so signs, units, and restrictions stay visible. Step 3. If variables cancel, evaluate the numeric statement that remains. Work efficiently without skipping an operation. Step 4. Report one solution, no solution, or infinitely many solutions precisely. Whenever possible, verify with evidence independent of the original working. Signal 1 is same variable coefficient after simplification. Respond by remembering. Expect an identity or contradiction. Name the response before calculating. Signal 2 is true statement such as 0 equals 0. In that case, every value in the domain is a solution. The form tells you which tool fits. Signal 3 is false statement such as 4 equals 9. Remember, no value can satisfy the equation. This separates plausible from valid answers. If you cannot name the signal, slow down. Deliberate classification is faster than repairing rushed algebra. Here is the challenge. Classify 3, 2x minus 5, plus 7 equals 6x minus 8. Restate the target and identify the most important part of the routine. The first move is distribute. 6x minus 15 plus 7 equals 6x minus 8. This changes the form without changing the meaning. Next, combine constants. 6x minus 8 equals 6x minus 8. Keep the relationship visible and apply the operation to every required term. Now audit distribution, signs, copied values, and restrictions. A brief midpoint check is cheaper than rebuilding the solution. Continue with the third step. Subtracting 6x leaves minus 8 equals minus 8, a true statement. State what the transformed line tells you. Complete the argument. Therefore, every real x satisfies the equation. This is part of the solution, not decoration. The final answer is infinitely many solutions. Compare it with the requested variable, expression, unit, interval, or classification. Verify from another direction, substitute, compare representations, inspect units, or test a boundary. Prove that the result satisfies the original conditions. Try this checkpoint without copying the example. After simplifying, you obtain 5 equals 12. What is the solution set? Decide which mathematical fact controls the answer. Write one line of reasoning before you commit. A visible decision is easier to inspect and correct. The focus hint. A false numerical statement cannot be repaired by any value of x. Use it to repair your setup rather than guess. An accepted answer is no solution. Explain why it works and name the first step that would expose a common error. The central message is, recognize when variable terms cancel completely. Combine it with the discipline to distinguish a contradiction from an identity. Finish by remembering to connect algebraic outcomes to parallel or coincident graphs. This turns a calculated result into a justified answer. Reflection. Why does a disappearing variable not automatically mean no solution? Name the error specifically so you can interrupt it next time. Practice one fresh problem within 3 minutes, including a verbal classification. Keep the work readable, check it independently, and carry the routine forward.